Alright, welcome back. We are going to start our next section, and our next section is going to be about graphing, functions, and linear relations. So new topic, new notes. Follow along. I'm not going to do a video recording of my face, I'm just going to do the document camera recording because I don't have good light right now and it makes my face just like a bright white glare. So graphs, functions, and relations. All words you've heard before, maybe not words you've necessarily used in the context we're going to use them. So I want to begin just by doing some basic definitions. What is a graph? You all know what a graph is. You all see them, but do you know the definition of it, a graph? Well, it's a tool, a mathematical tool, used to describe data in a visual form. It shows relations between variable quantities and the graphs we're going to work with here and the ones we're going to typically work with are two variables along a pair of axes. Make sure it's in focus, check. Typically shows the relation of two variables. Along a pair of axes. Axes, A-X-E-S, is the plural of axis, A-X-I-X. Okay. What are axes? Lines on a graph to set, scale, and quantity, and to quantify values. Okay. When we're working with axes, we're working with independent, or dependent axes. So, what's an independent axis? Axis, singular, independent axis, a variable whose variation does not depend on another variable. Well, that's just a lot of words, Mr. Gaffney. What's that even mean? For examples. Time. Time's always moving forward, no matter what we do. Let's say you're counting things. Apples, plates, people at a hotel, or your games played. These are just examples. This isn't a full list. Now, dependent variable. Or dependent. Oh, independent axis, forgot a major thing. Independent axis is traditionally the x-axis. The dependent axis. The variable that depends on another. That depends on another variable. So, let's say I'm measuring time and distance. Well, time is my independent one. It doesn't matter. Time's always going to progress forward. If I want to measure distance traveled per time, I need to know my distance. That would be my independent. So let's say counting, the sum or the total. How many goals you scored. How many passes you made. How many times you high-fived. 0. It's COVID-19. You shouldn't be high-fiving. And the dependent axis is usually the y-axis. Let's take a step back. The x-axis. Well, no, we'll do this next. Okay. X and y axes. The x-axis is the horizontal axis. Horizontal, left to right. We'll draw one in a minute. The y-axis is the vertical axis. The origin is the point where axes intersect. Or cross. Coordinate points. Now these are just a few graphing terms: x-axis, y-axis, origin, coordinate points. coordinate points. Are the values in an ordered pair. And represented x comma y in parentheses. What's an ordered pair? The values which define the location of a point based on the x and y axes. Axes. Okay, I'm going to pause it for a minute, do a few things, and we're going to continue on another. All right, back to page 2. All right, so we've talked about the y-axis, the origin, the coordinate points, ordered pair. What does it mean? So, what does a graph look like? Let's draw a graph. I don't have... Oh, I guess I can. Usually you should use a ruler. I'm going to draw this freehand. Evenish, pretend it's straight, we're playing pretend. So let's label some parts on a graph. Well, the line going left to right, the horizontal line, is the x-axis. The line going up and down, vertical, is the y-axis. Get used to identifying them, labeling them, that way in case you do have a situation where it's different letters, you are able to deal with it. The point where they intersect is the origin. Now we've talked about ordered coordinate points, ordered pair, that type of thing. Something like this . 2, 1. That would be a coordinate point or an ordered pair. Well, what does that mean? Oh, excuse me. What does that mean? Well, it identifies a specific location. It's like a specific address, a specific house number, somewhere where you know you need to go. Okay. Well, how do you plot them? Let's say I want you to plot 3, 4. What does that mean? Well, you need to be able to identify the x and the y. It's always going to be x, y. X value is always first. And what does the x value tell us? Well, the x is the distance from the y-axis. So the distance left and right from the y-axis. So if x equals 3, that means we're 3 units over. Well, if this is 2 units over, well, this is 1, 2, 3 units over. It's going to be somewhere 3 units over up here, 3 units over down here. We don't know. So the y value is the distance from the x-axis. So if x equals 3, then the point is 3 units to the left. I'm sorry, right. Of the y-axis. Okay. If y equals 4, I'm sorry. Then the point is 4 units above the x-axis. So what would that look like? Well, I'm going to take this trusty old box. Let's draw an X. Okay. That would be your y-axis. That would be your x-axis. Now, ideally, I have another ruler to be able to increment it properly. The origin is always going to be 0. I'm not any left, right, up or down from the y-axis. Going this way, the numbers get positive. 1, 2, 3, 4, 5. Going this way, that would be negative. -1, -2, -3, just like a number line. -4. Now these ideally would be all exact same distance, and going up would be +1, +2, +3, +4, +5. Going down would be -1, -2, -3, so on. All right. So let's pick a point. Let's pick a point 2, 3. All right. If I'm plotting 2, 3, I know that x equals 2 and y equals 3. So +2. It's going to be 2 units over from the y-axis. Well, this is the y-axis. This would be 1. This would be 2. I am going to say, hey, this vertical line is the line x equals 2. Every point along this line has a value of x equals 2. The only variance is the y values. The y values are going to be different as you go up and down along it. Think of a sliding vertical scale, like when the doctor's measuring how tall you are. All right, similarly, y equals 3. Y equals 3, it's a positive number. It's going to be above the y-axis. 1, 2, 3. That gives me a line that looks very much like that. A y equals line is horizontal, parallel to the x-axis. I am labeling my lines so we know what line I'm working with. And these lines, these are two straight lines. They're not parallel to each other. They will intersect at some point, and that point is, what color am I going for here? I guess it doesn't matter. Go back to this one. This is 2 from this. Oh, this is 3 from the x-axis. So the point where they intersect is going to be the xy. It's going to have an ordered pair of coordinate. In this case, it's going to have a specific x. What is my x equal to here? 2. What is my y equal to? Along this whole line, the y is equal to 3. So I have the point 2, 3. Okay. Let's try another one. This worked well. This wasn't quite what I was planning, but it's working okay. Take your time recreating these. X, y, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. And that's 0. The origin 0, 0. All right, let's say I want to draw a line x equals minus 2 and y equals 1. So drawing those lines, well, x equals minus 2. X equals minus 2. Minus tells us we're going to be to the left of the y-axis. 2 units over. Well, this one's 2 units over. So is this, so is this, so is this. And if you went through, you'd find that this is a vertical line. Perfect. Let's pretend. X equals 2. Awesome. Great. Grand. Wonderful. Y equals 1. I guess I didn't ask a question here. Draw a line of this and identify the intersection point. Black pen. Y equals 1. Well, it's going to be above the x-axis, 1 unit, all the way across. It's going to be this line here. Y equals 1. So, where do they intersect? They intersect right here. What's the value of x? Oh man, I made a mistake. X equals minus 2. What's the value of x at that point? Negative 2. What's the value of y at that point? Positive 1. Ordered pairs are always in parentheses. Minus 2, comma 1. I'm going to give you some examples to work on that to be able to plot and identify the numbers. But it's not something that's very challenging. Take your time, work on it. What else did I have in my notes? Oh, relations. I don't want to get into relations today. I just want you to practice your graphing. I will define relate. No, I don't have enough space. I'm going to keep it to these 2 sheets. I'm going to post a few other assignments. I'm going to scan these notes in. So that's all for today. I hope you've learned something from me. And I look forward to speaking to you soon. Thank you.